Welcome back to another chemistry video with Mr. Morin. Today we're going to look at how do we name acids. Now, you're going to learn a lot more about acids later on in your chemistry course. Things like what are their properties, how do they behave, how do they react. For right now, all you really need to understand is how to identify if something is an acid. So whenever we have hydrogen bonded to either a nonmetal or a polyatomic ion, we're going to assume that that's going to act as an acid. And there are two different types of acids that we're going to be dealing with. We have binary acids and oxyacids. And there's a few big differences between how we're going to name those. So in order to name them correctly, we have to be able to identify them. So what is a binary acid? Well, binary means that it has two parts. And we just said that to be an acid, one of those parts has to be hydrogen. So a binary acid means that we only have two elements that we're dealing with, one of which is hydrogen. So it's going to be when hydrogen is bonding with a nonmetal. Okay, so when we have hydrogen and one of these elements bonded together, that's going to be an acid. So to name that, we're going to use the word hydro. Now this word hydro is going to cause confusion. You don't use it on every acid. The problem is that many students think hydro goes with hydrogen. Hydro tells us it's binary. If it's the other type of acid, we don't use the word hydro. So please be careful, when do we use hydro and when do we not? So if it's binary, meaning we just have hydrogen with a nonmetal, we're going to use the word hydro. We're going to name the nonmetal that hydrogen is bonded with. We're going to change the ending of that nonmetal to "ic," and we're going to add the word acid. Okay? The word acid is what tells us we have hydrogen, because that means it is an acid, which means we have to have hydrogen. So an oxyacid has more than two elements. In an oxyacid, we're going to have hydrogen with a polyatomic ion. So we're going to have hydrogen, and it's going to bond with one of our polyatomic ions. With either of these types of acids, whether it's binary or oxy, the number of hydrogens that we have is going to be dictated by the charge of what it's bonded to. For example, if I had something like carbonate with a -2 charge, I would have to have two hydrogens to balance that out, because hydrogen is +1. So however much negative charge we have, if it's -1, -2, -3, that's how many hydrogens it will take when those things bond together. The same idea for our nonmetals. If I have hydrogen with chlorine, well, it's +1 and -1. If I have hydrogen with sulfur, because sulfur is -2, I'm going to need two hydrogens. Okay? So we do care about charge with acids. With our oxyacids, we're going to name those by not putting the word hydro. Not putting the word hydro there tells us it's an oxyacid, and we'll look at some examples. We're going to name our polyatomic ion, but we're going to change the ending. If it ends with "ate," we're going to change it to "ic." If it ends with "ite," we're going to change it to "us." So whether it's "ate" or "ite," we're going to change it to either "ic" or "us." So we have to be very careful when we're looking at these endings, how they end. Whether it's "ate" or "ite," it'll change whether it's "ic" or "us." And then just like before, we're going to put the word acid at the end. So the best way for this to make a little bit of sense is to do some examples. So if I look at an example here, HCl, I identify it as an acid because we have this hydrogen in front. Now that's not perfect. There's more than a couple types of acids, and some of them don't have hydrogen at all. But for right now in our chemistry course, this is a great way to understand it. So if we have hydrogens in front, it's going to be an acid, and we're going to name it as such. So if I have HCl, I know it's an acid, so I have to choose. Which kind of acid am I dealing with? Binary acids have just hydrogen and another element. Oxyacids have polyatomics. I don't have a polyatomic ion. I have hydrogen and chlorine. So I'm going to use the word hydro, name the nonmetal, change the ending to "ic," and then throw the word acid on there. So if it's HCl, I would call this hydrochloric acid. So we have hydro, we've changed the ending of chlorine to "ic," and then we put the word acid there. Okay? Good job. So now if I want to go from the name to the formula, the biggest giveaway that this is an acid is it literally tells you acid. Now we need to figure out what kind. This is why hydro is so important. If it has hydro in front, we know it's binary. If it doesn't have hydro, we know it's an oxyacid. This does not have hydro in front. So I know I need a polyatomic ion for this thing. How do I know which polyatomic ion to choose? I look at the endings. This is nitric, ic, and ate go together. So I need to look and see, well, here I have nitrate. Nitrate would change to ic. So NO3 with a -1 charge is the polyatomic ion that we're going to be dealing with. So I'm going to take my -1 charge from nitrate, and that tells me I need 1 hydrogen, and it's going to be HNO3. So I know it's NO3 because that's nitrate, and 8 and ic go together. I have 1 hydrogen because NO3 has a -1 charge. Let's look at another one. We have H2SO3. I know it's an acid because we have our H in front. I need to choose if it's binary or oxy. Because I have more than 2 elements, I know it cannot be binary, so it's an oxyacid. So what we need to do is look at the part that hydrogen is bonded with. This is SO3, and that SO3 has a -2 charge. I know that because there are 2 hydrogens. These hydrogens are +2, which means my SO3 has to be -2. So hopefully at this point you're starting to memorize your polyatomic ions. SO3 with a -2 charge is sulfite. That ending is important. Ite changes to us. We don't use hydro. We're just going to call this sulfurous acid. Okay? Let's look at one more example. We're going from the word to the formula. So we have hydroselenic acid. Obviously it's an acid because it says acid. And it has hydro in front. That hydro tells us it's binary. So we just have hydrogen and an element. What is that element? Well, if this is selenic, then that means that we have selenium. What charge does selenium have when it bonds? -2. So if it's -2, I'm going to need 2 hydrogens to go with my Se. So we get H2Se. So that's quickly a couple examples on how to name acids. The things that you need to really focus on. When do you use hydro and when do you not? How do I change the endings of my polyatomics? And how do I know how many hydrogens to use? The number of hydrogens is going to correspond with the amount of negative charge that it's bonding, of the bonding part, whether it's an element or a polyatomic ion. So the names of some of these can look really similar. It's very important that we're understanding our rules. Here's a handful that are very similar looking. Hydrochloric acid, perchloric acid, chloric acid, chlorous acid, and hypochlorous acid. All of these sound and look very similar, and their formulas sound and look very similar, but they're going to behave pretty differently when they bond or when they react with different things. So if I were to use hydrochloric acid when I really needed to use chloric acid, that could cause a lot of problems. So if you were needing to use a specific chemical and you use the wrong one, you could get a reaction that you didn't expect. You could produce a product that you did not want, especially if it's something like one of these and you end up making chlorine gas. That could be a bad day for everybody in the lab. So make sure you're being careful, whether it has hydro or whether it has these different prefixes and suffixes. They mean a big deal on the other end when we go to write a formula. So hopefully this video helped a little bit and you can name acids now. So thank you for listening and have a good day.